Today we are going to continue talking about the law of signs, but we're going to talk about a special case of the law of signs called the ambiguous case. So to lead into this, we're going to talk about this problem first. So I want to solve for theta. I want to figure out the angle that gives me 1/2. Okay, so let's go ahead and do this the way we would when we solve for angles. We talked about that yesterday. Move that over, we get inverse sine. So inverse sine of 1/2, make sure you're in degrees, and we plug this into our calculator. And we find out that this is 30 degrees. So normally we'd say, hey, this is 30 degrees. But what I want to do is I want to refer this back to the stuff that we learned and we talked about when we learned the unit circle. So if we have this, we would say, okay, there is a angle of rotation here at 30 degrees. And that angle of rotation is what has a y value, because that's what we're looking for with sine, of 1/2. So we find out that, we'll point on the edge of our unit circle out here at 30 degrees. This one has the y of 1/2. And we knew this from our unit circle. We know this is √3/2, but that's not really important about what we're doing right now. But we also need to remember when we look at this, there's other places that give us that 1/2. And more importantly, where it is, there's another one over here in the second quadrant, because we could also rotate this far, where the reference angle over here is 30 degrees, and we also are going to get a y of 1/2. And then what that means is that that angle of rotation right here is actually 150 degrees. Meaning that this should have an or with it. This could be 150. If we take our calculator and we plug in the sine of 30, we're going to see 1/2 on our screen. If we plug in the sine of 150, we also get 1/2. And what that means is that answer is ambiguous. It means it's not set defined. Both of these actually make the statement true. Now, that's troublesome when we start solving for triangles, because 150 just so happens to be less than 180 degrees, meaning that there's a possibility that this 150 could fit in one of our triangles and make it so that we would get more than one answer when we go to solve for an angle in a triangle using the law of signs. And that's what the ambiguous case is. Now, this only happens in one specific setup. And I'm just going to flip to this slide for a second. This has to be side-side angle for the information that you're given to start. And if you remember all the way back to when you learned your triangle congruencies way back, there were two of them that didn't work. One of them was side-side angle, and the other one was angle, angle, angle. We're only going to really talk about side-side angle, but we never talked to you or told you why it didn't work. The reason side-side angle didn't work is because of this. There's a possibility that this other or angle could fit in as one of our answers for our law of signs for finding that angle. So we have to be careful when we go and check both of them, okay? So there's a possibility that we could end up making two triangles, given that we start with a side, and an angle not in between them. We could have an acute angle when we solve for it, or we could fit an obtuse angle in there, and it's going to give us a second triangle that we could possibly make. So one tricky thing you got to look out for when using law of signs, you can have two answers possibly. This only happens when you know two sides and an angle not in between them, okay? And what could happen is that angle that we solve for could be an acute angle, or it could be the obtuse angle that goes with it. So let's actually set this one up and see this in action one time. So we want to find the measure of angle R. So angle R is down here, and it is opposite the side of 41. 39 and 28 are paired together. Now, information that we start with. We know two sides and an angle not between them. So when we go to use the law of signs now, we need to look at this. Is the information I'm given two sides and an angle not in between it? The answer here is yes. So what it means is we need to check the second angle, because the second angle might fit this time. So we're going to start this just like we did before. we're actually going to go through and set up our two fractions and we'll solve. So we have 41 over the sine of that angle R is equal to 28 over the sine of 39. We're going to cross multiply just like we did yesterday and solve this thing. So that's 28 sine of R, and that's equal to 41 times the sine of 39. So let's go through all our algebra steps here. So that's going to be 41 sine of 39 degrees divided by 28, and then to move the sine over, we get the inverse sine. So that angle R is going to be the inverse sine of 41 sine 39 divided by 28. And let's go ahead and plug all this in the calculator. Make sure you're in degrees, folks, because we're plugging in degrees. So 41 sine of 39, and we're going to divide that by 28. And we're going to take the second sine of that. So second sine of that is 67.1. 67.1 degrees. Now I'm going to erase what we had highlighted up here because we're going to kind of fill in the blanks of what we're finding. We're finding angle R. So what we just figured out is this angle from what we just said was 67.1 degrees, which fits because 67.1 plus 39 leaves us room for a third angle in our triangle P, so it actually has measure. But what we just talked about before, we know that there's another angle that this could be, where it has a reference angle of that 67.1, meaning the actual angle of rotation is 180 minus 67.1, which is 112.9. So that means the other one that'll give us this answer is 112.9 degrees. So let's write that there. This first one's always going to fit in our triangle. This is the one we need to check. This could also be 112.9. Now the way that we determine if this works, well, we say, well, 112.9 degrees plus 39, apologize. And we need to know, is that less than 180? Because we need to know if we have enough room left over for the last angle. So 112.9 plus 39 is 151.9 degrees. So that means this is less than 180, meaning that this last angle over here could also take on two variables. One of them could be 28.1 degrees. Or if it was 67, it would be, let's do that 67.1 plus 39, and then figure out what's left over. 73.9. It also means that this side right here is going to have two answers because it fit. It doesn't guarantee, just because we start with a side-side angle, that it's going to fit and it's going to make two triangles. But there's a possibility that it could. So what we have to look for is we always need to check it. And this one, of course, I made it work. So that means this angle has two answers, guys. But it only happens if we have side-side angle when we start. If we don't have two sides and an angle not in between them, we don't even have to check it. This is the only time that we have to check this second angle, okay? So what this looks like, though, if we look through this, so I have a little bit more layout here, we found out that we could have 67 or 112.9. So we actually get two different answers that are possible. We get a triangle that looks like this. Has a 67.1 degree angle down here. Or that other angle over here could have been this smaller triangle with an obtuse angle in here, 112.9 degrees, because both of them leave me room for this third angle, which I'm going to fill in on this slide for us, because that means one time that angle could be 73.9. Or we found out the other one was 28.1. all we're doing here is saying that all the angles of a triangle add up to 180, and because there's two possibilities for this one right here, we just have to make sure there's enough room to fit the third angle in there. If there is, that means that this particular setup gave us two possible answers for all those things, okay? This is confusing, so I know it's tough. I know this is different. We're learning online, so reach out, ask me for some help, guys, okay?